Alex from Deep Cycle Power, and in today's video I want to show you how I fixed an HP battery used for EVA8400. So I replaced it with lithium-ion cells, and I will show you the process of doing this. The board on top is the battery management that charges all the cells and checks that everything is running fine. This big IC right here communicates with the servers to tell the condition of the battery. If there was any fault on the battery, this chip will retain the fault and mark the battery as bad. We'll have to reset that as well. And over here we have two resistors that must be changed in order to accommodate the lithium-ion batteries. Otherwise you risk overcharging those cells and bad things will happen. I set my iron to 420 degrees. So it has enough heat to remove the cells. Show you what's the motion. When I hit one pole, I push the battery and it will extract a little, and then I do the same on the other side and pull the battery, push again, pull until it gets free. After you remove the cells, you'll be left with this PCB. I have to clean the contacts. I'm using this suction pump to extract the solder. For the first resistor, I got to use a 1.1K resistor. and for the second resistor it's 100K. Set the temperature to around 380 degrees. Now, before installing the cells, I have to reset this peak, like I said. I'm using this clamp right here to connect with the IC. You'll have to find the pinout online for the device and make the connection properly. If you don't have such clamp, you can remove the IC to program it easier and then place it back. I'm using Picket 3 with MPLAB IPE software. And the device also needs a 5-volt power supply to power on. The Picket 3 could not give the precise voltage, so I had to give it my own power supply. Inside the software, you have to select the device, which in my case is PIC 16F189. Connecting to the device should show you that the target device was found. To view the EE data memory, you have to go to Window, Target Memory Views, and select the EE data memory. If you want to read the IC, click the Read. And here you have all the memory with the events that happened with this battery. To make this battery as brand new, you have to erase this data, plug the battery in, and it will write a new memory. I already did this, so I'm going to import my working hex file. My workflow was that I erased the memory, I plugged the battery in, it started charging, I removed the battery, I read the PIC again, and then I have saved the hex file with this process already done. Because when you erase the memory, the EVA will write the PIC again. So I wanted to make sure that I avoid any issues when the EVA tries to write to the memory of the IC. So that's why I saved the already programmed one. I'm going to erase the IC. And choose to program it. Reading the IC should give you a file that looks something like this. You see mine has these zeros right here and some other bits that are changed in memory. You can try copying the same or follow the workflow I described earlier. Now this BMS module is ready to receive new cells, and I'm going to show you my process of building the cells for such battery. The right capacity for this, so I chose two cells that are around 2400 milliamps, and I will use them in parallel like this. this like this. We will end up with something that looks more or less like this for the positive side. Now it's time to create a lid for the negative side.